This video will cover the Geometry Common Core exam from June 2015, question 36. Number 36 says, in the coordinate plane, the vertices of triangle RST are R, S, and T. Prove that triangle RST is a right triangle. In order to prove something is a right triangle, we have to have a right angle. And in order to get right angles, we must find perpendicular lines. And in order to find perpendicular lines, we must have opposite reciprocal slopes. Opposite reciprocal slopes are just flipped and negated from one another. So for example, if we have a slope of, say, -4/3, its opposite reciprocal would be +3/4. Or if we have a slope of +2, its opposite reciprocal would be -1/2. So I'm going to take a second just to plot these points. I don't have the next page on this current slide, so I'm just going to kind of sketch it out. But you should plot these points on the next page because it's very helpful to actually have them on a graph. So pause the video, plot them on the next page, and then hit play when you're ready to go. Okay, so I got some graph paper here. I plotted the points R, S, and T. And now our goal is to prove that the triangle is a right triangle. And again, that means we have to have a right angle, which means we have to have perpendicular lines, which means we need opposite reciprocal slopes. So we need to calculate some slopes here, but I don't want to do too much work. You can do all of your slopes for each side, and that would be fine. But looking at the triangle, it looks as though the right angle is here at S, which means that I need to calculate slopes for TS and RS. In order to calculate slopes, we like to make a nice, beautiful chart with change X, change Y, and then slope, which is change Y over change X. Now this triangle, each time I write the triangle, you hear me saying the word change. Change means to subtract. So I'm going to subtract my X values for TS. Sometimes it's helpful to write the points right beneath it or off to the side. Like T is -5, +6, and S is 1, -4. That way you don't get confused. X's are stacked right on top of each other. So now I have -5 take away 1. And for Y's we have 6 minus -4. So now when we actually do the calculation for change X, we have -5 take away 1 more. That's -6. And then here for change Y, we have a double negative in the middle, which then turns to positive. So now we have +10. 6 plus 4 is +10. When we find slope, we do change Y over X. Y is to the sky. So that's 10 divided by -6. But we always want to reduce. I can divide each of these by 2. So 10 divided by 2 is 5. And -6 divided by 2 is -3. Then I'm going to calculate for RS. So first I'm going to list the coordinates beneath it. 6, -1, and 1, -4. So subtracting X's, I have 6 take away 1. Subtracting Y's, I have -1 take away -4. 6 take away 1 is 5. -1 minus minus, double negative turns to positive. So -1 plus 4 is +3. Y is to the sky, so 3/5. When we take a look at this, I have 3/5 and -5/3. These are opposite reciprocals. So now I can make a conclusion. We put these 3 little triangles, which mean the word therefore. Therefore, TS is perpendicular to RS. Because just like in a T-chart proof, you have to back up your reason, or back up your statement with a reason. Because opposite reciprocal slopes. But that's not all that's happening here. So we're going to add on a little bit with it. So angle S is a right angle. And if you're wondering how I figured out that it's S, not only by looking at the picture, but also by looking at the two sides we have perpendicular. They both have S in common, so the angle must be at S. Now that I've stated I have perpendicular lines, I can now conclude with therefore, triangle RST is a right triangle because there is one right angle. And we're done for that part. But of course there's more. There's always more. So the second part says state the coordinates of P such that quadrilateral RSTP is a rectangle. Now in order to be a rectangle, I need opposite sides congruent. And I need 4 right angles. Those opposite sides also need to be parallel. So right now I have one right angle. And in order to create parallel sides, I can find the slope of SR, which we already did, is up 3 over 5. Up 3 over 5. So I'm going to do the same thing from T to get P. Up 3 over 5. So here is my point P. So if I just use a different color here, we have P, T, S, R is now a rectangle. So I have to state the coordinates of P. P is located at 0, comma, now I'm just counting boxes here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, comma 9. And we're on to the next part, and you'll see that in just a second. Okay, so this next part says prove that your quadrilateral is a rectangle. So we're going to do a proof similar to that of proving a right triangle, but this time we're proving a rectangle. And in order to prove a rectangle, like we mentioned on the previous page, we need opposite sides parallel and one right angle. So I need to talk about all 4 pairs of sides. So I'm going to list each pair, and I'm also going to list the coordinates underneath. So R is located at 6, -1. S is located at 1, -4. And I'm going to make a nice, big, beautiful chart here. So at this point, I'm going to suggest that you pause the video because I'm going to pause this, and then when you play the video again, you'll see all of my tables set up. Whoops. With the next segment being ST, and then I'm also going to do PT and PR. And again, just listing those coordinates underneath. Okay, so I have my table set up, and I'm going to remember that my columns are supposed to be change X, change Y, slope, and I'm also going to put Pythagorean Theorem in here, because if you don't remember that a rectangle has opposite sides parallel and one right angle, then you want to calculate all of these pieces, change X, change Y, Pythagorean Theorem, and slope. That way you have all of the information in your table here, and you could get a 4 out of 6 on this question if all of the previous work is correct. So I'm going to start doing some calculations. Change, remember, means to subtract. So 6 minus 1 is 5. -1 minus -4, double negative turns to positive. So -1 plus 4 is 3. Change y over x, y is to the sky, 3 over 5. Now in order to plug into the Pythagorean theorem, the change x becomes your a, the change y becomes your b, and you're looking for c. 5 squared plus 3 squared equals c squared. 5 squared is 25. 3 squared is 9 equals c squared. 34 equals c squared. Square root both sides. So you find c equals square root 34. So now you're going to follow through with that process for the next several parts of this proof. When you hit play again, so you're going to pause the video, when you hit play again, you'll see my answers up here to check with yours. Okay, so I have all of my answers here. You may have struggled a little bit because, say for example, in the slope of ST, we have 10 over 6, negative 10 over 6. That reduces to negative 5 over 3. If you can reduce, you should reduce. When calculating Pythagorean theorem for that, I made sure that I went back to my original change x, change y to make that a and b. Plugged in and I got c equals square root 136. So take just a second to check your answers with mine. So when I'm looking at my picture or my paper with this big chart, I'm noticing several things happening here. RS and TP have the same slope. So that means that these two lines are parallel. So I'm going to actually make a statement right now. Therefore, RS is parallel to TP. I also notice that I have another pair of same slopes. So these two lines, ST and PR, are also parallel. So I'm going to say and ST is parallel to PR because same slope. But just like we recognized the last time with the right angle before, between RS and ST, I notice that I have opposite reciprocal slopes, which tells me that RS is perpendicular to RT. Therefore, RS is perpendicular to RT because this time it's not same slope, but it's opposite reciprocal slopes. So, angle S is a right angle. And I just realized that I actually made a typo here. I said RS is perpendicular to RT, but it should have been RS is perpendicular to ST. And again, that was RS and ST. So angle S is the right angle. Now that I have parallel lines and perpendicular lines with a right angle, this shape is actually a rectangle based off of that information. But if I wasn't sure, then I would definitely want to continue concluding things, such as RS is congruent to TP because they have the same length. Or ST is congruent to PR because they have the same length. If you're not sure how to prove a particular shape, then do everything in your chart and conclude everything in your reasons. But now that I have just enough parallel lines and a right angle, I can conclude that RSTP is a rectangle because both pairs of opposite sides are parallel, just like from our first conclusion we found, and there is at least one right angle. And that's from the second conclusion. So we're making a bunch of therefores, and then we make a final therefore using those two conclusions.